All right, what's going on, everybody? We are moving on with lesson 5.2, identifying triangles. Okay, so our objectives are to identify and classify triangles. Some of this I'm sure you may have already learned in a previous school year, but we're going to go through it. Okay, there are two ways to identify triangles. You can identify triangles by their side length and by their types of angles. Sorry about that. Also, just a reminder, you can always go into Canvas if you go here to the courses, right? The notes for 5.2 and the PowerPoint slides for 5.2 are there, so you could find those there. Anyways, back to there, right? By side length and by types of angles, right? So identifying triangles by side length, you have three types. You have an equilateral triangle. An equilateral triangle has all three equal congruent sides. An isosceles triangle has two equal congruent sides, and a scalene triangle has no congruent equal sides. Okay. Also, remember in last lesson in 5.1, we learned about congruency lines. We see you can tell that they are congruent to each other by the congruency lines, right? 2 matches 2 matches 2, so all three of them are equal. 1 matches 1, so those two lines are equal and congruent. There's no congruency tick marks or lines, so none of them are congruent. Identifying triangles by angles. An acute triangle has all three acute angles, right? All three of the angles are acute. Review, acute means less than 90. A right triangle has one single right angle, right? You can always tell the right angle by the box. An obtuse triangle has one obtuse angle, right? One angle that is larger than 90, two angles that are less than 90. And an equiangular triangle has all equal angles, right? So similar to equilateral triangle has equal sides, equiangular triangle has all equal angles, right? These are all end up being 60 degrees. Okay. So again, review from what we did last lesson in 5.1. Congruency lines is how we can tell when we have either congruent sides or congruent angles. Okay, some example problems. Identify the following triangles by both their side lengths and their angle types. Well, by side length, we see that we have congruency line, congruency line, congruency line. All three sides are equal, so that means it is equilateral. Right? And by angle type, we see that we have 60, 60, 60. That means they are all the same, which means that it is equiangular. But also notice all of these are 60. They're all equal, but they are all also less than 90. So that means this could also be labeled as an acute triangle because all of them are less than 90. Okay, by side length, we have two congruency lines, which means two equal sides, which means it is an isosceles triangle. And notice we don't have any of the angles told to us, but it's very obvious that this here is a big angle, definitely bigger than 90, so that means this is an obtuse triangle. All right, here by side length, we have a side length that's 3 inches, a side length that's 4 inches, and a side length that's 5 inches. Obviously, none of them are congruent. They are all different, so therefore that is a scalene triangle. And we see that we have the right angle box here, so that means we have a right triangle. Okay, so always can identify triangles by two different ways, side length and by angle type. Okay, again, just some more examples. Let's do this. Pause the video if you want. Try and figure that out on your own. Okay, by side length, let's take a look. Notice no congruency lines, no numbers, so we don't know exactly what all of the numbers of these side lengths are, but we can tell that there's no congruency lines, so therefore this is a scalene. And we see that 30, 70, 80, all of these angles are less than 90, so that means it is also acute. Okay, by side length, we see that we have two congruency lines, so two equal sides, which means isosceles. And we have a right angle, so therefore it's a right triangle. Right. All right, by side length, 1 tick mark, 2 tick marks, 3 tick marks. None of those match. That means none of them are congruent, so therefore we have another type of scalene. right? And again, no numbers in our angles, but this angle here, very obviously bigger than 90 degrees. So this is an obtuse triangle. Okay, by side length, once again, two congruency lines. That means it is an isosceles. All right, again, no actual numbers. We know that these two angles are congruent to each other, but it doesn't say what numbers they are. But again, very obvious. All of these are less than 90 degrees, which means they are acute. Okay, so again, just some examples for you. Okay, now talking about the angles of triangles. Interior angles are the original angles inside of the triangle. So when you think of a triangle, you know that it has 3 points, therefore it has 3 angles, right? So the interior angles, it's kind of hard to see, but they are actually shaded in red here, right? Interior angles on the inside of the triangle. Exterior angles are outside the triangle, and they also form linear pairs with the interior angles. So again, maybe not the best picture, but we see that shaded in blue are the exterior angles. Here, here, and here, right? And you see that they form linear pairs with the interior angles. So again, if we put in red the interior angles, right, we see that they form linear pairs here. They form a linear pair here, linear pair, linear pair. Notice none of these vertical angles out here are considered exterior angles, because that means they would just be the same side as the interior angles. Okay, the triangle sum theorem. Maybe you knew this already, maybe you didn't. This is, I think, one of the coolest things that happen in life and in geometry. The sum of the interior angles of a triangle will always add up to 180 degrees. So no matter what the number is for angle A, what the number is for angle B, what the number is for angle C, whatever those numbers are, if you add them together, they will always add up to 180 degrees. Okay, and now the exterior angle theorem says that the measure of an exterior angle is equal to the sum of the two opposite interior angles, right? So if we take a look here, angle 3 is in green, right? It's here in green. That's an exterior angle because, look, it forms in a linear pair, right? That forms a straight line with that interior angle. Now, the exterior angle is equal to the sum of the two opposite, right? So opposite means away from. We see that if we just point away from where angle 3 is, it points away to these two angles, right? So if you add those two together, it will equal the angle of adding together an angle 1 and adding together angle 2 will always equal the measure of angle 3. Oops. Okay, so some examples. Find the measure of angle A. The way that I always like to set these problems up, we know that we have 3 angles in a triangle, and they will always add up to equal 180. So if I have 3 spaces, they all have to add up to equal 180. Plug in what we know. We see that we have a 99. We see that we have a 41, and we don't know what this is, right? We can have a question mark there. We can put a question mark there. We can put an X there. We can put a variable. It doesn't matter, right? So now we solve for let's go ahead and put the X there. Right, let's put X. So 99 plus 41 gives you 140 plus X equals 180. Right, if we're solving, we want to find X, so we got to get rid of 140. So we subtract 140 here, those cancel, and we get X is equal to 180 minus 140 is 40. So that means the measure of angle A here is 40 degrees. 40 degrees. Okay, another example, find the measure of 2 angles, right? Angle 1 and angle 3. Notice angle 1 is an exterior angle, right? And if we point away from this, right, opposite, away from these angles, that means that angle 1 is equal to the opposite 2 interior angles. So that means 18 plus 40, which means that angle 1 is equal to 18 plus 40 gives you 58. So the measure of angle 1 is 58. All right, now if I use a different color, notice we have angle 3. Angle 3 is an interior angle, so we have 1, 2, 3 interior angles, and we know that those 3 interior angles will always add up to equal 180. And we have 18, we have 40, and we have angle 3, which we don't know. Let's put an X there. All right, add them together. Well, we already did that, so 58 plus X equals 180. Subtract 58 from both sides. Those cancel and we get X is equal to, let's solve this out. We have to borrow, so that's 7. 10 minus 8 is 2. 7 minus 5 is 2, and 1. 122. So angle 3 is going to be 122. Now, also notice, fun facts, right? If I erase some of this to get this out of the way, right? Angle 3 we found was 122. And then we found that angle 1 was 58. Well, if you notice, 122 plus 58 does end up equaling 180 because this creates a straight line. These are a linear pair. Okay, that's another easy way that we could have found it. Yes, we did end up adding 18 plus 40, but once we found out that angle 1 was 58, we could have just gone straight to 58 and subtracted it from 180 to find out that our answer is 122. Okay, now if you have variables, once again, we still have three angles in a triangle, and we know that they're always going to add together to equal 180. Right now we just have multiple x's here. This is one angle, so we plug it in x. We still have one angle here, we plug it in 3x, and we still have one angle here that's given to us, it's 60. Okay, combine like terms, x plus 3x is 4x plus 60 equals 180. Sorry, I'm going to run out of room here. But if we subtract 60 from both sides, I'm going to rewrite back up here. Now we end up with 4x equals, those cancel out. 180 minus 60 is 120. Now if we divide by 4, we get that x is equal to 120 divided by 4 is 30. Okay, so x is equal to 30. Remember, though, this angle is x, so that angle is 30, but this angle is 3x, or 3 times x. And if x is equal to 30, 3 times 30 is 90. So that means that angle is 90. And if you want to double check your work, 60 plus 30 is 90, and now 90 plus 90 does also add up to equal 180. Okay, over here, this is an exterior angle, right? That's exterior, so that means the opposite away from, add those two together, will equal x, because x is the exterior angle, so we just add those two together, 64 plus 70, and we get that x is equal to 64 plus 70 comes out to 134. So the measure of angle x is 134. I believe that is all that I have. Yep, nothing else. Go team, go Mustangs.